has a second input, V sub B, and it also has a color mode. And you notice between the two, the color mode is attached to each one of them. So this is considered a random noise interference. And if the idea is we're trying to amplify V sub A and V sub B, however, at the same time we have these large color mode waveforms on the input also. So the purpose of this circuit is to amplify the difference between V sub A and V sub B, and at the same time reject this color mode waveforms called V sub C. Now this, if we refer, this has two channels on it here. So we're going to refer to the one channel is channel A and the other one channel B. So the non-inverting input will be channel B, the other will be channel A here. You notice here we do not ground the non-inverting input for this amplifier. So, but we still have the virtual ground effect because we have this negative feedback resistor. So both signals have the same noise on the input. Now, in order to design a circuit to reject these color modes, we have 4 resistors to design with. So we need to find an equation for this amplifier, and then we can get into how we're going to actually set the values of these resistors to get this color mode rejection. Over here, we can do some math here, and it's not necessarily, this wouldn't be on the exam, but it's just to basically study the circuit because we're trying to develop an equation for V out versus V1 and V2 on the input. So we just noticed the current in this pin is I1, here is I sub 2. The voltage on the positive, the non-inverting input is a resistor divider, and since I1 is equal to, is the same on both sides here, we can set both of these currents equal to each other, and now when we substitute V plus and V1 in here, we get, this is the equation that we get at the bottom here. And again, here's V sub out, the equation for V sub out. Again, this equation is not in the best form yet. So we'll keep manipulating the equation. We modified some more, and now we have V sub 1 has some R2 or R1, and V sub 2 has another resistive component on it. And now we notice that V sub out is really just R2 over R1 times V2 minus V sub 1. So this is, even though these equations, when they were developing them, they look rather complicated, the result is simple. We end up kind of going in a circle because all we get up with, this device is only going to amplify the difference between V1 and V2. However, it still doesn't make it obvious how it's going to reject common mode signals. So we'll go back in, and V sub 2 and V sub 1 contain V sub B of T, V sub A of T, and they also contain these 2 color mode inputs. So we go back to the original formula for the op-amp gain, and this is the equation that we have. And we want to remove these V sub C components. And again, even with this attempt, we still get the same equation here, because we're going to assume the color modes are canceling out right here. But we still do not have a formula that shows how we're going to cancel. Notice the color modes both have a non-inverting polarity, so it looks like they're going to actually add up. So this says if with this input, this say we're basically going to attempt to design the circuit. We're going to take two resistors, R2 or R1. This is just the gain of the op-amp. So let's say we set that to 100. We have 10 volt power supplies, and let's assume the channel 8 voltage is 0.01 sine 25 plus 1000 T. And then it also has a DC offset of 2 volts on it. And let's assume the signal going into channel 2, which is V sub B, is 2 volts. So what do these two signals have in common? The 2 volts. So the 2 volts is the color mode interfering waveform. The desired signal is V sub A. At the same time, V sub A contains a color mode, and then the second channel also has a large 2 volt color mode on its input. So we're going to assume we're going to reject the 2 volts, and if we put it in the math for V sub B minus V sub A, we get 2 volts minus this 2 pi 1000 plus 2 volts. So mathematically, the 2 volts cancels out here. And we only get out the inverted 1000 T waveform. So mathematically, the design is pretty much complete. But it still doesn't explain how we get, how do we remove the 2 volts in here. In math it happens, but the circuit is still not designed yet. So the output is only going to be the sine 2 pi 1000 T, and it will not contain the 2 volts interfere. Now if we run this in here, now for your homework, let's see if we can go ahead. For your homework assignment, we're going to return to this, and then we'll go through the equation here. But in order to be convinced that the circuit can actually behave of rejecting the 2 volts input, this is a simulation that we can try.